The dawn of graphene. When scientists tried to reduce graphite down to a thickness of one atom, they stumbled onto an amazing discovery: graphene. It turns out, when a graphite is super thin, it takes on new properties and characteristics. In this presentation, I'll enlighten you in regard to graphene and its amazing potential in modern technology. A basic sample of graphene can be made right here where you're watching this. Just take a pencil, scratch a few lines on a piece of paper, get some scotch tape and apply it to the lines on the paper. When you remove the tape from the paper, you've now created a new product, graphene. The remnants of your pencil's graphite that adhered to the tape will be about 1 atom thick. In other words, on your tape is a sample of graphene. This process is actually how the first scientists discovered graphene. Graphene contains unique properties unlike its parent graphite. As graphene is only 1 atom thick, it can be used to make bendable electronics when graphene is used in place of silicon in electronic circuit boards. Graphene is a semi-metal, non-conductive material. Graphene electrons can cover micrometer distances without scattering even at room temperatures. One of the most useful properties of graphene is that it is a zero overlap semi-metal with very high electrical conductivity. Carbon atoms have a total of 6 electrons, 2 in the inner shell and 4 in the outer shell. The 4 outer shell electrons in the individual atoms are available for chemical bonding, but in graphene, each atom is connected to 3 other carbon atoms on the 2-dimensional plane, leaving 1 electron freely available in the 3rd dimension for electrical conduction. Another of graphene's outstanding properties as its inherent string to the strength of its carbon bonds. Graphene is the strongest material ever discovered. What makes this particularly special is that graphene also contains elastic properties, being able to retain its initial size after strain. Graphene's ability to absorb a rather large percentage of white light is also unique and interesting property, especially considering that it is only 1 atom thick. In terms of how far along we are to understanding all of the properties of graphene, this is just the tip of the iceberg before graphene is heavily integrated into the areas which we believe it will excel at. We need to spend a lot more time understanding just what makes it such an amazing material. This article caught my attention because out of the many different topics I researched, this one was the most advanced and had the most potential in the future. The information was very in-depth and thoroughly explained. Since graphite will be the key in modern technology, as a young chemist, this field would be most appealing to us. This article was written by George W. Flynn from Columbia University, New York, et al. It had many citations, making it very legitimate. Graphene is a material with remarkable mechanical, optical, and electronic properties. Despite the intense activity in graphene studies over the past few years, there remains much to be discovered about this single atom thick substance. For a chemical physicist, graphene offers a near perfect opportunity to work in an exciting field that requires sophisticated measurements, challenging theory, and opportunity to collaborate with synthetic, inorganic, and organic chemists. Could we ask for anything more? Thank you for watching my presentation. I hope it was interesting as it was to me. ScienceDaily.com is where I discovered the interesting topic of graphene, and EBSCOhost is also where I found the article to research. The Journal of Chemical Physics 135 in 2012.